When we come back, you should have the answer. I'm just going to write it here. Now, this is the second time that we let you guys do a stop and jot, and we really want you to be accountable and responsible for your learning. So please make sure that you are writing down the answers on your own before you look at ours. So the answer that I have here is 17 plus 9 is 26, plus 8 would be 34 feet. So altogether we need 34 feet of fence to fence in for this shape. Okay? So that's the first part. Now the next part, we're going to have to find out what the area is. Okay? So, I'm going to erase all this so we can focus on the area now. I'm going to break it to two shapes that I know. Okay? This time I'm going to break it up going vertically because you always see me do it horizontally. I'm going to do it vertically this time. Okay? So I broke it up into this is a shape here and this is another shape over here. Okay? So I break this down over here. As you can see, from here to here, that's the part that we need. It stops here. It's not the whole 9 feet. It's right here, which is 4 feet. And from here to here, we have 8 feet. That is my first shape that I brought up. Over here, we break it down. We have from here to here, we see that our mystery, remember, was 5 feet. So this is 5 feet here. And from here to here is 3 feet. And we all know that area equals length times width. So please take next couple seconds, 20 seconds to figure out the area of both these shapes. This should be very fast. Mental math, come on, think about it. Okay, so thank you for pausing and trying that. Area equals length times width. I multiply these two. 8 times 4 equals 32 feet squared. Okay, remember it's squared, not just feet, because we're multiplying two lengths by each other, so it's squared. Here we have 3 times 15, 3 times 5, which equals 15 feet squared. Okay, so I put these answers, I bring it back to my Legos back together. I know I have 15 feet squared here, and I have 32 feet squared here. Okay? Now, I know that this is not the final answer. I must add them together. 32 plus 15 equals 47 feet squared. Now, what I want you to do is for your last part of these 3 problems, we're not going to tell you which one was the best one. We want you to think about this. What was the best shape to put the most kids in for homework detention? Okay, which one of these shapes? Bring that back to us after Christmas, and if you're the first one here, you'll get a gift. Okay. Here we have, kids, Rocketeers will be able to add fractions with unlike denominators. You guys can do this. We know you can. And this is a skill that you'll learn until the 5th grade. And I taught high schools this too. So Ms. Patel is going to lead us off and be persistent in paying attention to the video.
All right, let's say that I had a bucket of apples and I had a bucket of oranges. And I had 10 apples and I had 3 oranges. Then altogether I had 13 pieces of fruit. Those could be apples, it could be oranges, they could be blueberries. But by calling it fruit, I know what I have. It's still not that specific, though, is the problem. With fractions, it's kind of the same thing. I have 3/4 and I have 1/2. So if I were to add these together, is my answer going to be in terms of fourths or in terms of halves? We have to make sure that we're talking about the same type of piece. So we could be talking about fourths, we could be talking about halves. Now, in this case in particular, it makes more sense to not talk about either of those and use a common denominator. Now, the way I can find a common denominator is by multiplying these two things right here. So my denominator for both of these is going to be 4 times 2. So I have eighths and I have eighths. And I'm going to talk about both of these fractions in terms of eighths. Now remember, let's say I did have 3/4. To find an equivalent fraction with eighths, all I really need to do is give it a haircut. I'm just going to take another slice. So now in eighths, that's 1, 2, 3, 4, 5, 6. That's easy to do with a picture, but it's even easier to do with just numbers. I'm going to take this denominator and multiply it by this number. 2 times 3 equals 6, which is exactly how many eighths it shows I have in my picture. Going to the other side, let's say I had 1/2. Now to talk about it in terms of eighths, all I have to do is give it a haircut. So now I have 1, 2, 3, 4 eighths. And that can be very easily done through the problem. 4 times 1 equals 4 eighths. So now all I really have to do is add these fractions that have the same denominator. I know exactly what I'm talking about. I'm talking about eighths here. Not fourths, not halves, but all of this is in terms of eighths because I found a common denominator. 6 plus 4 equals 10. And the denominator stays the same. So my answer is 10 eighths. If you notice, this is called an improper fraction. The top, or the numerator, is larger than the denominator. That's not really the way we usually like to write our fractions, so Mr. Link is going to walk you through the process to find a decimal answer that makes a little bit more sense.
Okay, so as Ms. Patel just went through, she told you about how you should cut the hair. Mr. Link is actually going to cut his hair when he goes back home, so sorry. But that's to the point what we're doing. So this is the improper fraction right here. We know what an improper fraction means. It means our numerator is greater than our denominator. We can't do anything with this, so we're going to turn this into a decimal. We all know that fractions mean we are dividing. This is really saying 10 divided by 8. Okay, remember, 10 over 8 means 10 divided by 8. Okay, so now one thing that we all know, and I'm going to say, top goes in. That's what division is all about. Okay, so we all know it. Top goes in, bottom goes out. That's what division is all about. So we put the top inside the division box. The numerator goes out. And we see, how many times can 8 go into 1? We know it goes into it 0 times. 8 times 0 is 0. 1 minus 0 is 1. Bring down the 0. Divide. Multiply, subtract, check. Bring it down, bring it down, bring it down. So we're going to bring it down again. We're going to divide, multiply. So 8 goes into 10 one time. Multiply 8 times 1. Subtract, check, bring it down. So 10 minus 8 is 2. Now we have to bring down a 0. But what did Mr. Link just do? I added a 0. It went from 10 to 100. I can't do that. That's just changing the number. We know that. So if I'm bringing down another 0 after the number, I must put a decimal here. Okay, so there are decimals here. So the value is still 10. It's not 100. It's 10. Now, how many times does 8 go into 20? 8 goes into 20 2 times. Subtract. I'm borrowing. 10 minus 6 is 4. I bring down another 0. 8 goes into 40 5 times. Okay, so I get 1 and 25 hundredths is what this will be in decimal form. Hey guys, welcome back. Okay, welcome back. We're getting serious now. We're back to getting serious. Adding fractions with unlike denominators. As you remember, Ms. Patel specifically told us that we must have common denominators anytime we want to add fractions. I have the problem here. 2/3 plus 6/7. As you can see, our denominators are not alike. They're different. They're unlike denominators. So I'm going to teach you a thing called Zorro, okay?